Section 7.6, example 5, solving a dependent system. Solve the system of equations. So we have a system of equations here. I don't know, something's telling me that it might be dependent. All right, starting off with grabbing the system of equations and putting it into a matrix. We have 3, 4, and 12, 6, 8, and 24. No pretty way of doing this, so we're going to have to multiply equation 1 by 1/3. So 1/3 times row 1 for the new row 1. Again, to get backwards, to get a 1 where we need it first. So getting a 1 where we need it first. Row 2, we're not manipulating at all, so let's just rewrite that one. And now let's get this part done. So 3 times 1/3, it's going to be 1. 4 times 1/3, it's going to be 4/3. And 12 times 1/3, it's going to be 4. Perfect. Now what we're going to do is, now that we have a 1 where we need it, we're going to get a 0 in that exact same column. And we could easily do that by just multiplying by the opposite of whatever we're trying to turn into a 0. So opposite of +6 is going to be a -6. So -6 times row 1 plus row 2. What we're trying to manipulate is row 2. Row 1 is not being manipulated whatsoever. So 1, 4/3, and 4. And now let's see what we have. We have 1 times a -6 is -6. -6 plus 6 is going to be 0. Perfect, just what we needed. And row 1 times, all right, so 4/3 times a -6, that's going to be 4/8, so a -8. And we have -8 plus 8, it's going to be 0. Ooh, look what we have so far. All right, so now lastly, we have 4 times -6. It's going to be a -24 plus a +24 gives us 0. And now this is very different from what we had earlier. Earlier in the previous problem, we had 0. We had 0 equals -4, so 0 will never equal -4. But here we have 0 is equal to 0. So that tells us that we have infinitely many solutions. Many solutions. Which means we are dependent. And last thing that we have to do is show what the situation is. So our situation is going to be in the form of x, comma, some other values. So we have an input for x and we have to figure out what the output is. So here, what we'll do is grab either one of the equations, because what this proved right here is that both of the equations are the exact same thing. So what we'll do is just grab that first one. It has smaller numbers. So 3x, 4y, 12. So 3x plus 4y equals 12. And we're going to solve for y to see what our y component of our what the y component of our solution is. So solving for y here, subtract 3x from both sides, We have 4y is equal to a negative 3x plus 12, divide both sides by 4. We end up with y is equal to a negative 3 over 4x plus 3. And that's what y is in our solution. Y is equal to a negative 3 over 4x plus 3. And this is our solution. There we go. If you have any questions whatsoever, please feel free to ask. Otherwise, bye.